So in this lesson, we're going to be taking what we learned about intermolecular forces and seeing how that affects changes of state of matter. So just as a quick review, if you start with a solid and that solid becomes a liquid, that's known as melting. If that liquid becomes a solid, it's freezing. Okay? If a solid becomes a gas, like what happens with carbon dioxide with dry ice, that's called sublimation. So solid to a gas is sublimation, gas to a solid is deposition. Then if that gas becomes a liquid, it's condensation, while if a liquid becomes a gas, that's called vaporization. And what you should notice on the right-hand side, this is what's called the heating curve. So if you look at it, if you start at the very bottom, that solid is heating up to 0 degrees. Okay? Once it's at 0 degrees, it plateaus, and it plateaus because the solid is going from a solid to a liquid. In order to have a state change, what's actually happening is you are breaking the intermolecular forces, which we studied, that are holding those molecules together. So that's why the temperature does not change. Then, when you're at 0 on that far side as a liquid, then the temperature is going to increase if you put in more energy. The temperature is going to increase until you reach 100 degrees Celsius. Now this is for water, it's going to be different values for other compounds. Once you hit 100 degrees, then you plateau again, and that's because the liquid is becoming a gas. Now notice this plateau is much longer than that for melting, and the reason why, when you melt, you do break intermolecular forces. But when you go from a liquid to a gas, you have to break all of the attractions between molecules. So as a result, it takes a lot more energy for a substance to boil, to go from a liquid to a gas, to be vaporized, than for it to melt. And then once you're at the end of that and you're completely a gas, then the temperature of the gas can continue to increase. So that's a heating curve. So let's talk really quickly about melting and freezing. In order for a substance to melt, a solid to melt, heat must be put into the system. Okay? And so that makes it endothermic. The heat is going to be positive. For a liquid to become a solid, okay, heat is going to be released. And that happens with freezing. That's why heat is released when you have a freezer. That's why you have a fan under your fridge in order to release some of that heat, or else your fridge would get overheated because the process of going from a liquid to a solid releases heat. So let's talk about a term that helps us in order to determine the heat that's involved in this melting and freezing process, and that term is your heat of fusion. So the heat of fusion is the energy that must be added in order to convert 1 gram of solid to a liquid at the melting point. So we're going to use this value, which will always be given to you, in order to calculate heat that's involved when, for example, ice melts. Okay, so if I have 15 grams of ice, I'm going to convert this into joules by using my heat of fusion. So I'm going to put grams on bottom, joules up top. Then the heat of fusion is 334 joules for every 1 gram. And so I get the heat that's required, or heat that's absorbed, to be 5,180 joules. Okay? So let's look at this for your other state changes. Specifically, let's look at vaporization and condensation. Okay? In order to calculate the heat that is involved with the vaporization or condensation process, okay, we're going to be using this heating curve a little bit later on, so I just wanted to include it there for you to see what's happening. You're at that top plateau right there where boiling is happening. Let's actually calculate this. Well, we need to use the heat of vaporization for this, and so the heat of vaporization is the energy that must be added to convert 1 gram of liquid to a gas at your boiling point. And so it's nice, I like the heating curve because you can actually see these processes. That plateau at the very top, that is the heat of vaporization. So let's actually calculate the amount of heat that's needed to vaporize 33.8 grams of water. So if I'm given 33.8 grams of water, if you notice, your heat of vaporization is actually in kilojoules per mole. So I've got to first convert these grams into moles. So I'm going to put grams on bottom, moles up top. I'm going to put the molar mass of water on bottom. Now I'm in moles. Now I can use my heat of vaporization. So I'm going to put moles on bottom, kilojoules up top, and then I'm going to put the 40.7 over 1 mole. All right? So now what I get when I do that math, I get 76.3 kilojoules of heat is required to vaporize that water. Okay? So what happens though if I'm not just doing a state change, and instead I'm also changing temperature. Well, then we're going to have to go back to the concept of specific heat, which we've already talked about. So what I require for these problems, when they're multi-step problems, I require you to explain what's going on, actually verbalize what's going on as you do the math, okay? Really quickly, as an aside, if you notice, just to reinforce the fact that more heat is required to vaporize versus melt, if you notice the heat of fusion for water is only 6.02, while the heat of vaporization is 40.7. And that's simply because you're breaking all of the intermolecular forces between a liquid and a gas, while for a solid and a liquid, you're not breaking all of them. Okay, so this question asks you to calculate the total heat in joules needed to convert 25.0 grams of ice at 0 degrees Celsius to a liquid at 25 degrees Celsius. So I'm starting as a solid at 0, so that's right at the beginning of the first plateau. I'm going to move across that plateau to become a liquid, so I've got to melt it, and then it has to go from 0 degrees Celsius up to 25 degrees Celsius. So this is going to be a two-step problem. So the first step is going to be going from a solid to a liquid, all right? So since I've got 25 grams, what I can do to determine the heat required for that state change is I can use my heat of fusion. So I'm going to go from grams of water into moles of water, and then from moles of water I can get into kilojoules, and that will give me my heat that is required in order to melt that substance. Then for step 2, I'm going to go from a liquid at 0 degrees to a liquid at 25. So I'm going to be using my specific heat, which in your book shows up as SH. We learned it as C. Okay? So Q equals MC delta T, that should look familiar. I'm solving for Q here. So my Q equals the mass, which is 25.0 grams, times the specific heat. Notice the specific heat of a liquid and a solid are different. I'm using the specific heat of a liquid, which is 4.184. Then I'm going to multiply that by the change in temperature. Remember, change in temperature is T final minus T initial, so 25 minus 0, because I finish at 25. And I get my heat, which is 2,620 joules. In order to add these together, I've got to convert one of them into the other unit, so I'm going to convert into kilojoules. And then to find the total heat, all I have to do is add those together. Now notice the question asks you for joules. So instead of 10.97 kilojoules, this would be 10,970 joules for your final answer. So for these problems, guys, if you know for the steps that I actually wrote out, I wrote step 1, solid to a liquid. You have to write these out so I know that you know what's going on.